Hello dear leaners, my name is Muna Jones. Today, we discuss lactation. Development of fetal mammary glands begins at about 8 weeks of gestation. Rudimentary mammary ducts are formed near the beginning of the third trimester. Prolactin induces terminal differentiation of the ductal cells. Thereafter the mammary glands remain in a rudimentary state until puberty. First sign of female puberty is the growth of breasts. Hormonal control of breast development and growth. Gonadal steroids and a variety of hormones are essential for growth. Such growth has different times during pregnancy. During first half, there is mainly proliferation of alveolar cells and duct system. During the last half, the emphasis is on promotion of secretory activity in the alveolar epithelium. Estrogen functions. 1. Stimulate proliferation of mammary ducts. 2. Stimulate formation of lactis and casein, provided that insulin, cortisol T3, and prolactin are present. 3. Induce progesterone receptor. 4. Stimulate prolactin pituitary cells causing increased synthesis and release of prolactin. Progesterone functions. 1. Promotes differentiation of the alveolo-tubular system. 2. Inhibits alveolar secretory activity. Luteotropic hormone, prolactin. Functions. 1. Stimulates duct development. Glucocorticoids. Functions. 1. Stimulates duct development. Insulin. 1. Stimulates uptake of glucose into alveolar cells. 2. Promotes incorporation of AA into alveolar cells to form proteins. IGF-1 promotes mammary growth and development. Thyroid hormones promote ductal growth. Hormonal control of lactogenesis. Maternal plasma levels of P4, E2, and prolactin increase progressively during pregnancy. Within 48 hours after parturition, the levels of P4 and E2 return to non-pregnancy values because the placenta is no longer present. Prolactin levels remain elevated. Progesterone exerts a strong inhibition on the onset of milk production. Hence lactation begins within 1 to 3 days of delivery when P4 levels have fallen. Thereafter maintenance of lactation requires prolactin, oxytocin and mother-child interaction. The mammary glands secrete milk during lactation. When an infant is born, it loses its source of maternal nourishment through the placenta and must rely on an external source of food instead. A mammary gland is composed of about 20 milk-secreting lobules, each made up of branched hollow ducts of secretory epithelium surrounded by contractile cells. The mammary gland epithelium is closely related to the secretory epithelium of sweat glands, so milk and sweat secretion share some common features. The breasts first begin to develop under the influence of estrogen during puberty. The milk ducts grow and branch, while fat deposited behind the glandular tissue. During pregnancy, the glands develop further under the direction of estrogen, aided by growth hormone and cortisol. The final development step also requires progesterone, which converts the duct epithelium into a secretory structure. This process is similar to the progesterone's effect on the uterus, in which progesterone makes the endometrium into a secretory tissue during the luteal phase. Although estrogen and progesterone stimulate mammary development, they inhibit the actual secretion of milk. Milk production is under the control of the hormone prolactin from the anterior pituitary. Prolactin is an unusual pituitary hormone in that it is primarily controlled by an inhibiting hormone from the hypothalamus. There is good evidence that the prolactin-inhibiting hormone, PIT, is actually dopamine, an amine hormone related to E and northeast. During the later stages of pregnancy, HIP secretion falls and prolactin levels in the blood reach levels that are 10 or more times those found in no pregnant women. Despite the high levels of prolactin, the mammary glands produce only small amounts of a thin, low-fat secretion called colostrums because the levels of estrogen and progesterone are high. After delivery, when estrogen and progesterone levels decrease, the glands begin to produce greater amounts of milk that contains 4% fat and substantial amounts of calcium. Proteins in colostrums and milk include maternal immunoglobulins, secreted into the duct and absorbed intact by the infant's intestinal epithelium, so some of the mother's immunity is conferred on the infant during the early weeks of life. Suckling, the mechanical stimulus of the infant's nursing at the breast, inhibits the release of PIF from the hypothalamus. In the absence of this inhibition, the pituitary increases spontaneous prolactin secretion, resulting in milk production. Pregnancy is not a requirement for lactation, and some women who have adopted babies have been successful in breastfeeding. The ejection of milk from the glands, known as the letdown reflex, requires the presence of a second hormone, oxytocin, from the posterior pituitary. Oxytocin initiates smooth muscle contractions in the breast and uterus. In the postpartum, after delivery, uterus, these contractions help return of the myoepithelial cells surrounding the mammary glands. The contraction creates high pressure that sends the milk literally squirting into the infant's mouth. Although prolactin release requires the mechanical stimulus of suckling, oxytocin release can be stimulated by various cerebral stimuli, including the thought of the child. Many nursing mothers experience inappropriate milk release triggered by hearing someone else's child cry. All non-nursing women and men have tonic prolactin secretion that shows a diurnal cycle, peaking during sleep. This suggests that the hormone has other roles in the body, although at this point we do not know what they are. Some of the most intriguing research indicates that normal lymphocytes produce a prolactin-like peptide and also have prolactin receptors, so prolactin may play a role in body immunity, a topic that needs further exploration. Thanks very much for watching this lesson. Kindly share and click subscribe button for more educative content.